Good morning. Hi, good morning, and welcome to Tago's presentation of our Viscometers. Today, we're going to be looking at two different Viscometers. The two we have. The left here is our Visco, and on the right here we have our Visco BL. And we're going to be taking a look at both of them, the similarities, the differences, when you would like to choose this one, when you prefer this one, and some other aspects that they each have. If you have any questions, feel free to ask the questions in the chat, and we can either get to the questions right then, if it's something that we're reviewing, or at the end, the last 5 minutes of the presentation, we will also leave for your questions. Also, as you can see, we already have the instrument set up for you. In the description of this seminar, and also after the presentation, we're gonna be sending you two different links. Those links are the setup links of how to set this instrument up with a temperature controller and how to set this instrument up with a temperature controller. So yes, so we're gonna take a look at this Visco, that Visco, and a little about the temperature controller unit that we have, which is a Peltier system that controls temperature. And there is going to be a second webinar on specifically the temperature controller and how to use the environment, the temperature controls. It's going to be a bit more detailed. Today we're just going to show you the temperature controller. Okay. So to start off with, we can see that they both have very different form factors. Let me see if I can change the angle here. Okay, so this part of the instrument is the same, but this is our Visco, and it is our portable Viscometer, which means you can take it with you. It's very lightweight. This model, or the model this is made after, is the Visco 895, which is for aluminum. It has aluminum body, so it's very light to handle. So you can take it with you. You can take it over there. It's meant to be portable. This instrument is our bench top. As you can see, it's designed to be on the bench, on the table, and it's a tabletop Viscometer. Okay, so if you're the kind of person, like for example, an inspector, that you need to go to different locations to do inspection of samples, then this is the instrument for you. If you work in a lab setting, where you have everything already set, then this might be the instrument for you. Also, they both work with electricity, with AC and the DC power. So they both work with batteries, and you can plug them into the wall. For now, let me show you how the batteries are. So this is the temperature sensor that we just took off. So if you push this down and you unscrew this, you have these two, and each cartridge has two batteries. So this is battery operated, as well as you can plug it into the wall. This also has battery system, but I'm not going to show it. It's very similar. So you unscrew it from here. Let me see if I can turn this around instead. So you can unscrew this part, and you'll have the same 2 cartridges of batteries in there. You can pull those out. On the back of this here, you can see the USB that we're gonna mention later, where you can output the data via USB, and this is where you would plug in your power to the wall. Any questions so far on chat? Okay. Here, you also have the same outputs. Sorry, the power input and the USB output as the other Visco. And later we're going to talk about this controller here, which is the main controller for the instrument. So one of the benefits of these models of buying an Atago instrument is that the whole operation is done with one hand. So the blinking of the screen doesn't actually blink. It's blinking because of the camera settings, because of the frame rate of the camera versus the frame rate of the LCD. So if you see it blinking or scrolling, it's not that way in person. So anyways, what I wanted to show you is that both Viscos, you can just control it with one hand. You have the menu. Actually, from the video, you can barely see the menu, but I promise you there's a menu here, and you can scroll up and down the menu, and then you can click to select, and then scroll up and down. So with both instruments, it's very easy to use, and you can just use one hand to control it. Let me turn that on. Okay. So the next big difference between the two is volume. The Visco uses these 2 small containers. So if your sample is an expensive sample, if you have very little of your sample, low volumes of your sample, then the Visco is the version for you, because it uses very little volume of your sample to take a reading. The benchtop, the Visco BL, looks more like the traditional Viscometers, where it uses either a 500 or a 300 milliliter container to take the readings. So those are the big differences in terms of volume. Okay. Also, there are some people that in the supply chain have to compare their viscosity standards or viscosity readings with other brand viscometers like Brookfield or like THINHLAB, where those types are more of a traditional benchtop viscometers. Then if you want a closer comparison with those, let's say the RPM, the type of spindle, the volume of the sample, if you're going to be comparing those information, then you might want to go with the benchtop model, because of the volume of the Visco. It will not match up, obviously, with the volume of that those other brands are using. Okay. Any questions? Not yet. All right. So at this point, I want to introduce the spindles, which is also a big difference between these. The Visco has these cone type spindles. All 3 are cone types. Okay, and we've laser engraved them for you. A1, A2, and A3. Okay, that's for the Visco. For the Visco BL, or the benchtop viscometer, has one installed here. Give me a second. So we have these 4. We have the L1. And if you have used other brand Viscometers before, then these are more familiar to you. The L2, L3, and L4. Okay, so just to summarize, portable, benchtop, low volume, what should I say? The usual volume that you would be using, the standard volumes that other brands would be using. Cone spindles and the spindles that you're used to with other brands. Okay. Both are powered via AC or DC via battery or connecting it to the wall. Both have a USB output. Both are one-hand controls. And both can be used with the temperature controller that we're going to see in a bit. Okay. Today we're not going to review on actually using the instrument of choosing spindles or RPM. That's going to be a different class. Today we're just comparing both. So as you can see, this model, the benchtop model, you put the sample and you will lower the visco into the sample. Okay, this is the visco is a bit of the same, but it's more portable. Oh, sorry, I forgot to mention that even though they have different spindles or the different spindle design, or maybe I should install it and show you. Give me a second. Not sure. If you can notice, but the spindle has these 3 little lines here. These are for the sample, where the sample is supposed to be. So it doesn't matter the volume that you're going to use or which visco you're going to use. They all have those 3 lines. So this is the spindle for the visco, and you see it still has the 3 little lines. So those are guides for the volume of where you're supposed to set the spindle at. For the benchtop viscometer, it's a guide to how low you're gonna set it. So when your sample gets to that line, then you stop. Okay, so that guide for the benchtop is on how low you're gonna lower your visco BL. Yes.
So we have 4 questions so far.
Okay.
The first one is, are readings same in both for same sample or any difference?
If?
Are readings same in both for same sample or any difference?
Good question. They are not, how should I say? The reading would be the same. They're both viscometers and they'll read the same. So if you have a sample that is 1000 CP, it's going to read 1000 CP here, and it's going to read 1000 CP here. The difference is going to be with volume. Here you're going to use 500 milliliters, here you're going to use a lot less. And the difference also is going to be the RPM and the spindle that you're going to use. So maybe this is going to have a higher RPM than this, and obviously the spindles are going to be different, but the value is going to be the same. So if, for example, the reason I brought up the other brand refractometers is because I have a few customers that have never used a viscometer, and they just want some type of internal control or a quick control. So they buy the Visco. I have other customers that they're purchasing raw material from the manufacturer, from a supplier, and in the specs of the raw material, it says it has a certain viscosity if using a certain type of spindle at a specific RPM. So, and this amount of volume. So if you're going to use, so they're giving you the raw material, the viscosity, the RPM, and the spindle. That's going to be more translatable to this type. If you're going to use that type of information on this instrument, then it's not going to match the RPM. So the question was, is the sample going to read the same on both? In terms of viscosity, yes. In terms of the setting of each and the spindle that you're going to use, it's going to be different because they're two very different viscometers. If that wasn't clear, let me know.
The second question is about the sample range. So sample range same for both instruments.
Good question. No, the sample ranges are a little different. Sorry, I don't have access to that one right now. So the Visco, give me a second, let me. The sample range of the Visco, sorry, that caught me by surprise. There are different sample ranges, different viscometer ranges. Who asked that? Rajundi? I'll email you the details, the difference between both the Visco ranges. But that question also leads me to a different explanation. Thank you for asking that. So as you can see, this benchtop viscometer is one set of volume. So you have one set of volume and a set of spindles. Okay, your whole range is based on that volume, your RPM, and the type of spindle. Okay, with the Visco, you have two containers. Okay. So each spindle and container combination is a specific range. So even though the instrument has a wide range of viscosity, when you combine this spindle with this container, it's part of that range. And if you change it to this spindle, it's a different part in that range. And you change it to this spindle, and it's a different part of the range. And then if you use this spindle with this container, it's a different range, different section of that range, and you get the point, right? So yes, the Visco has a very wide range. The benchtop has a very wide range, but the range on the viscometer would depend on the combination of spindle and container that you have. So when you're going to measure your sample and you know what viscosity is your sample, then you need to look up at the user manual, and it'll give you a guide of, okay, if it's a low range, then you might go with this combination. If it's a high range, maybe you want to go with this combination. So different combinations give you access to different ranges.
So we have a lot of questions.
Yeah.
Thank you for the questions. And the third one is whether the machine should be labeled or not.
Yes, that is gonna be in the. Is it? It should be. Yes, both instruments will be leveled. You have these feet here, these adjustable feet here to level it. You're gonna put the legs there, and you're not gonna see it because of the refresh rate of the LCD and the frame rate of the camera, but you have an area where it says level. If you can focus camera. Okay, it says level, and then you have a digital level. There you see a square, and then you're gonna see a bubble. So then a digital bubble. So then I am going to. Do you see the bubble there getting close to the? Not too much. Too little. No. There, it's kind of centered now. Do you see? So that's how you would center. Do you see the bubble in the center? That's how you would center, or you would level this viscometer. The benchtop one is exactly the same screen, but obviously you have the feet. Let me see if I can show you without tapping it off. The feet are down there, and they're adjustable as well. The other question.
Next question is how to choose a spindle for a certain sample if we do not know its viscosity.
Very good question. You're basically looking for a specific resistance. How can I? Sorry, I just lost the word for it. Give me a second. Torque. Resistance. You're looking for a specific torque. So the way you would do it with both are a little different. One second, let me get out of here. Yeah, sorry, I can't show you. So basically, you're looking for a torque percentage. And sorry, let me turn this off. You want somewhere between around 80 torque percentage to give you like a value of your viscosity. If you put your sample and you hear this beep, like you do here, beep. Hope you can hear it. That beep means the torque is too low. The resistance is too low. So you need something higher, around 80, and that would be your viscosity, the viscosity of your sample. With the benchtop one, it would be the same, but with the benchtop one, there is a little bit more clear guide as to the viscosity standard, the viscosity of your sample. Also, can I have that user manual? Oh, not that one. Yeah, that one. The user manual of both instruments give you, especially Visco, gives you a clear image of what spindle and container to use. Where are you? All right, sorry, I can't find it right now. I thought it was up here. Okay, yeah. So basically it tells you low viscosity, choose a wider beaker and a smaller container, and high viscosity, bigger container and smaller beaker. And then so basically if you go off this guide and then you get your torque to about 80, 80, 85, 90, then that would be the true value of your viscosity. If you're, for example, for Visco, for this guy, you don't have a problem because it's just one volume with different spindles. But with the Visco, if for some reason you're using this container with all of, you tried all of these spindles and you're still not getting 80, sorry, the other way. If you're using this combination and you're still not getting 80 torque, then you might want to change to this and try these. And then when you get to 80 torque, then that's the value of your, that's the viscosity value of your sample.
Okay, the next question is about this V.
Yes.
Are there any spindles besides those presented?
There is one more, and Atago is continuously coming up with new options for you. The other option that I have that we were gonna see later, but thanks to this question, we're gonna see it now, is the low viscosity spindle. So this is the container for the low viscosity. This is your spindle for low viscosity. So if you have a low viscosity of between, I think it was 1 and 10 CP or MPS, then you're going to use this spindle on here, or you're going to use this spindle on here. And I know it looks like it's too big, but there's like a form factor that you need to change. We basically set the Visco on the on a new height settings that you would use it. So far, to answer the question, is those four and this one for low viscosity. I know there are or might be other spindles that are specialized spindles for other samples. We are always looking for new ways to improve our instruments, and little by little we'll be branching out into those.
The next question is, does the sample have to be homogeneous or inhomogeneous samples?
Yeah.
Can you also measure?
So yes, your sample depends. It doesn't have to be. But if your sample is not homogeneous, then the readings will spike a little or will be unstable. Because every time he spins and he touches a chunk or something that's not homogeneous, then that creates more resistance and the viscosity will go up a little. So yes, it'll read it, but it'll have repeatability issues. How much repeatability depends how much your sample is not homogeneous.
Another question, is there any compatible printer available which can be connected directly to the USB port of Visco instead of connecting?
Good question. Not yet. Right now, the way you would have to do it is send data to the computer, and then from the computer print out the information.
Okay. Another question, does the density of the sample reflect on the time of viscosity detection?
Does the density
of the sample reflect on the time
yes,
of viscosity?
Good question, and it also brings up another topic that I was going to review, which is kinematic viscosity. You can program the density of your sample here in the instrument to measure kinematic viscosity. It is an option. Yes, also the question was, does density affect the reading?
The time of viscosity.
Yes. Yes and no. Not only the density, but the speed of the RPM and the type of spindle. But it doesn't, if it affects it, it's for fractions of a second or at least a few seconds. It's not like exact, like more than 30 seconds to stabilize. It's just the initial when the liquid starts moving because of the spindle, that movement is delayed by the density, but it goes away very quickly.
The next question, how do we choose the speed in a sample?
Yes, so this speed is just a tool for you to get the torque. So depends on your torque. You want to adjust your speed to get the 80% torque that we were talking about. So if you're at a low speed and you're not getting enough torque, you might want to increase the speed to get the torque that you need, that you want.
Okay, the next one, the manual says the torque has to be more than 10, but you said 18.
Yes. So ideally, I mean, acceptable is more than 10, but from my preference, if you want to, how should I say this? From my experience, having the torque around 80-ish gives you the closest, most accurate result for some or most samples. If you're going to have the torque at 20, it will read a viscosity. But if you're going to compare that to a known sample, for example, like a standard, you're going to see that it is, if you have a torque of 20, 30, it is close to the real value. But if you want to get it real close, I mean, really accurate, then you would need a higher torque. 10, 20, 30 pulls it in the ballpark. But for accuracy, 80-ish is, from my experience, is what gives you the best readings.
Okay, last question. Can you show us how to use the ULA on 895?
Not today, because I think we're short on time. But there are videos. Who asked that question? Azri. We're gonna send you some more information. We have a few videos. In the video, sorry, let me introduce this guy. This is the temperature controller. Actually, this is the part that heats or cools down your sample. This is the temperature controller. Okay, so if you're using the Visco, you're gonna put it here, and inside here you're gonna put the different. This is not it. This is. You're gonna put the sample in there. You're gonna put your temperature and your temperature probe on your spindle there, and then you're gonna lower it there, and kaboom! You're gonna control it to start reading it. Okay. For the low viscosity, it's the same thing. You're going to hook the guy up to here, and then you're gonna lower it in here, and then you're gonna take the reading. But in the videos in the description and in other videos that are coming up, we're going to, I don't read Japanese. Can someone write in English? Thank you. We can, you're gonna show you how to use the low volume spindle. Okay. Any other questions? No. All right. Then thank you very much for joining. If you have any other questions, please let us know and email us. We're here to help. Thank you.